Okay, so we go on to the second rule, which is the chain rule. Now, remember, just a recap, we said that we are doing differential calculus, okay? And we said that there's no better place than to start from than to look at limits, okay? Once we understand limits, we can now go to derivatives, okay? Once we begin to look at derivatives, the best place to start from is to understand the limits definition, because this touches all forms of derivatives, okay? Then the next step is now to look at the rules that simplify the limits derivatives, okay? And so the first rule that we said we looked at was the power rule. And so the second rule is going to be the chain rule, which is an extension of the power rule, okay? So how does it work? So if we had, let's say, a function, okay? Let's say we've got a function here, and our function is y is equal to fx, right? Then this fx has got a power, let's say n, okay? So the chain rule seeks to help us with, let's say, a function like this, plus 1. This would normally use a chain rule, the power rule. But what if this was to a certain power, let's say 2? We can't just use this n and forget about the contents here. Okay, so the contents are not singular, okay? Like, let's say x2. Okay, there's a combination of terms here. So we can't just use the power rule. There's got to be another method. So here we say that the change in y over the change in x is going to be found how? We look at the contents first. So we find the derivatives of the contents. So for example, here we'll have 2x as the derivative. So meaning that the derivative of the contents is going to be this function here. Okay, so the derivative of that function, we said that we can also represent it like this. Okay, or you can say d fx over dx. It's the same. I like to avoid clutter, so I will say this. Okay, then what's the next step? We haven't finished because we just did the contents. What about this power now? Okay, so that power comes down as always. So we use the power rule. We say now we're going to ignore the contents, okay, and just deal with the shell. Okay, so the shell now is going to be n comes down, right? And we maintain our brackets. Then our function remains intact since we're going to ignore it, okay? But then using the power rule, this is going to be n minus 1. Okay, so this is the chain rule. And then some will actually tell you that you can actually make this into u, okay? So the function you can say now that u is equal to fx. Okay, remember, now this has become u. This is y still, okay? Meaning that we can say that y is equal to u power n. So now we've created two functions there. So now here, if I were to do the differentiation of this one, I can say this is du, okay, dx. This one here, okay, which is going to be fx, which we saw here, right? Then what about this one? Okay, that one becomes dy du, because now this is u, right? Which in this case is going to be n, right? We maintain the u, and then this becomes n minus 1, which is the same as what we had here, what we had there, meaning that we can also say that this same expression, okay, this same expression can be written as, we want our final thing to be dy dx, okay, meaning that it's going to be what? We are going to use this first because we want dy, so it's dy over du, okay, times what? Du over dx. So if we use normal algebra, you see that this and that can cancel, then we have dy du. So this is another form of this one here. Okay, so that is the chain rule. Let's do some examples.